Hi, Teepen here, and in today's video I'm going to teach you about this neat thing called a glider and how people use it to fly across the country. So first things first, what is a glider? You've probably seen people do things like hang gliding, but that's not the glider I'm talking about. A glider is an airplane, but without an engine. It harnesses the energy of gravity to produce flight. Now, a glider's main objective is to be able to go as far as possible on as little energy. As a result, gliders are built to produce a bunch of lift with as minimal drag. Let's break it down. So, first things first, the fuselage. You see, the fuselage is streamlined like a teardrop shape. The funny thing about a teardrop shape is that shape is best designed to reduce drag. There's something called the coefficient of drag, and the coefficient of drag relates different shapes and how much drag they produce when moving through a fluid. The teardrop shape has the lowest coefficient of drag, which means it is the best shape that produces the least amount of drag. Next are the wings. You'll see that gliders have really long, narrow wings. What that means is that the glider has a high aspect ratio. Now, I asked myself, what is an aspect ratio? Well, let me tell you. The aspect ratio is how long the wings are, known as the wingspan, divided by how tall the wings are, known as the chord length. And what aspect ratio tells us is effectively the efficiency of the wing. A high aspect ratio will produce a lot of lift for a low amount of drag, whereas a short aspect ratio will be more inefficient and produce more drag per unit lift. You can see this effect a lot in the difference between civilian and military aircraft. Civilian aircraft, they need to have very efficient wings. So if you look at a 737 per se, you'll see that they have very long wings that are kind of short and have a high aspect ratio. The downside about aspect ratio, though, is that the higher the aspect ratio, the less maneuverability you have. If you have an airplane with really long wings, you can't exactly do extremely sharp turns and loop-de-loops and all of the stuff that military fighter jets like to do. As a result, if you look at a military fighter jet, like this picture of the F-18 I have here, you'll see that it has short stubby wings that are rather tall. In other words, a very low aspect ratio. A low aspect ratio allows greater maneuverability and allows them to do the turns and the crazy wiggles that they like to do. However, the lower aspect ratio means that it's less efficient and produces more drag. But that's okay because the F-18 has two giant engines that produce a ton of power that can overcome whatever drag it faces. So that's not a big deal. The military would rather have the higher maneuverability to win in fights rather than fuel efficiency. Whereas gliders, they need to be able to go as long as possible on the least amount of drag, so they have a high aspect ratio. Now, let's talk about how gliders fly. So, first off, to get into the air, they need something that brings them up there. Because the space elevator hasn't really been invented yet, they have to use a powered vessel. And the powered vessel, it tows the glider behind it. So you'll have a small aircraft like a small Cessna that will power up and will take off towing the glider behind it. Then they'll cut the tow and the glider will be all on its own. Once it's on its own, its goal is to go as far as possible. And it can't do that just from where it cut off because the glider will just glide straight down and that won't be very far. As a result, gliders use different tactics and the way that the Earth works in order to be able to continue going higher. First thing are called thermals. So a thermal produces thermal lift. What happens is that you have different parts of the Earth that receive different heating. Say you have a desert area over here with white sand, and asphalt, which is nice and dark, and then more desert. Well, the asphalt, that is going to absorb a lot more heat and as a result radiate more heat. Because you have more heat on the surface, the air wants to rise. And what gliders will do is they will take that rising air and they will use that to lift themselves up. And what they'll do is they will just circle around over that asphalt patch and keep spiraling up and up and up and up, as far as the air will carry them. Another thing they do is called ridge lift. So ridge lift is produced near a mountain or any other formation of land that slopes upward. When wind comes, it encounters this mountain, and the mountain forces the air upwards. And what gliders will do is they will utilize that, because since the air is moving upwards, it'll push them upwards. And gliders have been known to just ride along ridges and surf that ridge lift for miles and miles and miles. The third way gliders produce lift is with something called wave lift. Now, wave lift is similar to ridge lift, but a little bit different. Instead of it being on the front side of the mountain where the air gets pushed up, what happens is that as the air comes over the mountain, the disturbance of air will produce kind of waves behind it. And gliders are able to see these waves by the formation of lenticular clouds. Waves are a greatly preferred method when it comes to gliders, because often the disturbance behind the mountain can be greater than the initial ridge lift caused by the mountain. And when gliders hang out on the crest of these waves, they can be pushed in excess of 35,000 feet, which is the cruising altitude of most common airliners today. Getting up that high means that they have a lot more to glide, and they can go extremely far. Using different tactics like these gliders can travel for hundreds of miles, and if someone was really ambitious, they could arguably travel across a state or half the country. If you like gliders and what you heard today, give me a thumbs up and leave a comment below. And with that, my name is Teepen. Feel free to check me out on social media or subscribe to my channel. Peace out.